Welcome to the session on quadratics. In this session, we'll be looking at functions, range and domain. The objectives for this session are to understand what the domain and range of a function is and attempt related exercises. A function is a mathematical relationship which maps every value of a set of inputs x to a single output f of x. The notation f of x is used to represent a function of x. The set of possible inputs for a function is called the domain, and the set of possible outputs for a function is called the range. Let's take a look at an example. The diagram will show how the function f of x equals x to the 4 maps values in its domain to values in its range. So suppose the domain consists of values 2, 4, minus 4, a third, and root 3. These all get mapped into the range. The 2 gets mapped to 16, that's 2 to the power 4. 4 gets mapped to 256, that's 4 to the power 4. Minus 4 gets mapped to 256, that's minus 4 to the power 4. A third gets mapped to 1 over 81, which is a third to the power 4. And finally root 3 gets mapped to 9, which is root 3 raised to the power 4. Now pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's solve example 1a. So we have two functions f and g given by f of x equals 3x plus 5 and g of x equals x squared plus 3, where x is a member of the real numbers. We are required to find f of 3 and g of 8. We're going to look at f of x first and plug in x equals 3 into our function. So when x equals 3, we have f of 3 equals 3 times 3 plus 5. This is where x equals 3 comes from, and then plus 5, which is part of the equation, to give us 14. Now for g of 8. We're now going to look at the function g of x and plug in x equals 8. So we have g of 8 equals 8 squared plus 3, which gives us 67. And now for example 1b. We are looking at the same functions, but this time we're required to find the values of x for which f of x equals g of x. So if f of x equals g of x, then 3x plus 5 equals x squared plus 3. So now let's rearrange so that we have an expression which is equal to 0. We take all the values over to one side. X squared plus 3 is here, and we take minus 3x and minus 5 away from both sides to give us x squared plus 3 minus 3x minus 5 equals 0. We now tidy up. X squared stays as it is. Minus 3x stays as it is. And 3 minus 5 becomes minus 2. And of course, all of this is equal to 0. We now solve by using the quadratic formula. Minus b is plugged in here. So minus b is, of course, minus minus 3, which is 3. B squared is minus 3 squared, which is 9. A is equal to 1. And c is equal to minus 2. And then we tidy up a little bit. And when we tidy up some more, we have x equals 3 plus root 17 all over 2, or x equals 3 minus root 17 all over 2. as shown. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2a first. The function f is defined as f of x equals x squared plus 8x minus 3, where x is a member of the real numbers. We're required to write f of x in the form x plus p all squared plus q. Applying the completing the square formula gives us that f of x equals x plus 4 all squared minus 16 minus 3. Tidying up gives us x plus 4 all squared minus 19. So now we have our function in our required format. This gives us that p equals 4 and q equals minus 19, as shown. And now for example 2b. The function f is again defined as f of x equals x squared plus 8x minus 3, where x is in the real numbers, and we're required to find the roots of f of x. From part A, we know that f of x equals x plus 4 all squared minus 19. So in order to find the roots, let f of x equal 0. So we have that x plus 4 squared minus 19 is equal to 0. Rearranging gives us that x plus 4 all squared equals 19. We square root both sides to give us x plus 4 equals plus or minus root 19. This gives us that x equals minus 4 plus or minus root 19. And now for example 2c, we find the minimum value of f of x. So from part A we have that f of x equals x plus 4 all squared minus 19. Therefore clearly x plus 4 all squared is greater than or equal to 0. In other words, the minimum value of f of x occurs when x plus 4 all squared is equal to 0. And this implies that x plus 4 equals 0. Or equivalently, x equals minus 4. So when x equals minus 4, f of x equals minus 4 plus 4 all squared minus 19. And therefore f of x equals minus 19 at x equals minus 4. So the minimum value of f of x is minus 19. This brings us to the end of this session. If you have understood its contents, you should be able to understand what the domain and range of a function is, and attempt the related exercises. Thank you very much for listening. In order to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.